Hi guys, so let's see these questions. These are on limiting reagents. So this is on page 6. So here you have 10 grams of ammonia reacting with 10 grams of carbon dioxide. So normally when you're provided with mass of both reagents or number of moles of both reagents, it means that there is one which is limiting and one which is in excess. So the first step is we'll convert the mass to moles for each reagent. So we have found the number of moles for each. From the number of moles and from the mole ratio, we're going to find the limiting reagent. So for this, there's two ways that we can do this. So let's see the two ways. We're going to look at the ratio. So 2 moles of NH3 reacts with 1 mole of CO2. Which means that if we have 0.587 moles of NH3, we can calculate the number of moles of CO2 with which it will react. So we'll just do proportion, so it's going to be half of this. So from the calculation, we find that the number of moles of ammonia that we have, based on the mass of ammonia that we are using, this number of moles of ammonia will react with 0.298 moles of carbon dioxide. It will need this amount of carbon dioxide to react completely. But based on the amount of carbon dioxide that we have been provided, so 10 grams, which is equivalent to 0.227 moles of carbon dioxide, so we don't have enough of carbon dioxide. So these two number of moles that you can see here, these are the number of moles of substances that we have. And the one that you're calculating here is the amount of carbon dioxide that you would need. But you would need more carbon dioxide than what you actually have, which means that the amount of carbon dioxide is less than what you would need if all the ammonia would react, which means that carbon dioxide is limiting the reaction from going further. So here carbon dioxide is limiting, because when you look at the number of moles of carbon dioxide that you actually have, this is less than what you are going to need to have the ammonia to react completely. So this is one way of looking at it. Another way is a more mechanical way of doing the calculation. So what you're going to do, you're going to write the two substances involved, ammonia and carbon dioxide. You write the mole ratio, 2:1. You write the number of moles that you have for each of them. And then you take the number of moles, you divide by the mole ratio. And you see the one that is the smallest value, so in this case this is the smallest value, so the smallest value will indicate the one that is limiting. So CO2 is limiting here. So it has the smaller value of the number of moles. This is another way of doing it, but be careful. The values that you're getting here, all these values, they have no significance for any further calculation. So please don't try to use these values for whatsoever calculation that follow up. Right? Next, we're going to use the amount of limiting reagent to find the amount of product, hence find the mass of product. So because carbon dioxide is the limiting reagent, we're going to use the number of moles of carbon dioxide that you have. So we're going to go back on amount of carbon dioxide that we have, which is here. So the product that we are concerned with is urea. So we'll look at the mole ratio between carbon dioxide and urea. So carbon dioxide to urea. So the mole ratio is 1 mole is to 1 mole. So number of mole of carbon dioxide is given here. So 0.2 227 mole of carbon dioxide, it's going to give you the same number of mole of urea. So using the formula of urea, we find the MR of urea. And then from this, we can get the mass of urea, which is going to be MR times number of moles. So it's just going to be the MR times the number of moles of urea that we're going to get. So this is the mass of urea, 13.6 grams, and I'm going to give my answer to 3SF, or you can give it to 4SF as well. Let's see example 2. You need to find the maximum amount of sodium chloride that can be produced when 10 grams of sodium is reacted with 14 grams of chlorine. So here, again, you have the two reagents and you have the mass of the two reagents. So we'll start by writing a chemical equation because this is where all the mole ratio are going to come from. Then we're going to use the mass of each substance and we're going to find the number of moles of each one of them. So here you do mass divided by AR because this is an atom. So we're going to be using AR, mass divided by AR. And then for chlorine, it's Cl2, it's chlorine molecule. And we are going to be using the MR, mass divided by MR. So you calculate it. Once we have the number of moles of each of the reagent, we'll need to find the limiting reagent. And for the limiting reagent, I'm going to go through the quick method. So we're just going to write the names of the reagent. Just mention the reagents, write the mole ratio 2:1, write the number of moles of each one of them. You divide by the mole ratio. And the one that is smallest, so this one is smallest, so this is the limiting reagent. So chlorine is limiting reagent, which means that when we're doing the calculations for the amount of sodium chloride that we get, we're going to use the number of moles of chlorine. So using limiting reagent, so 1 mole of chlorine gives you 2 moles of sodium chloride. Therefore, 0.197 moles of chlorine. This is from the calculation over here, not from the calculation over here. Values that you get over here are not going to be used for any calculation. Only the values obtained here when you're finding the number of moles. So this is going to give you twice. So here you have the amount of sodium chloride that is formed. Let's see the third example. So here you have the manufacture of phosphoric acid from phosphorus and oxygen and water. So here it tells you that you have 24.77 gram of phosphorus that is used to react with 100 grams of oxygen. So you have the mass of both of them, and it already tells you that water is in excess. So between phosphorus and oxygen, there is one which is going to be limiting. So let's find the limiting. We're going to convert the mass of each of them into moles. So using number of moles is mass over MR, you get the number of moles of both. From the number of moles, now I will need to find the limiting reagent. And for the limiting reagent, I'm going to use the equation. So I'm going to write the reagents that we have. So phosphorus and oxygen. Mole ratio 1:5 from the chemical equation here, and then I'm going to write the number of moles of each one, and I'll divide with the number of moles. So the one that is smallest is going to be the limiting reagent. So here this is smallest, so therefore phosphorus is limiting. So which means that for any further calculations, we're going to be using the number of moles of phosphorus, which is here. Now, to find the amount of phosphorus acid produced, we're going to be looking at the chemical equation. So phosphorus is to phosphoric acid. So 1 mole of phosphorus gives 4 moles of phosphoric acid. Therefore, 0.2 moles of phosphorus is going to give me 4 times that number of moles of phosphoric acid. So this is, in theory, how much phosphoric acid you're supposed to get. Now, then you have the last question, which is the mass of phosphorus acid. So mass would be number of moles times mR. So let's find the mR first. So this is the mR. Therefore, the mass would be the number of moles of phosphoric acid times the mR. So here's the answer. You can give your answer to 3SF or 4SF. I've chosen to give it to 4SF. You're going to try these as questions to practice on limiting reagent and just ignore question number 5.